All right, let's dive right into this explainer. Today, we're mapping out the Certified Kubernetes Administrator, or CKA exam, and exploring the absolute core technical concepts you need to pass it. Whether you're actively prepping for the test or honestly just want a rock-solid foundation in Kubernetes, we're going to break it all down for you.
So, here's our roadmap for today. We'll start with decoding the CKA exam itself, look at why Kubernetes even exists, explain the architecture, dive into pods and workloads, cover services and networking, and finally wrap up with troubleshooting for the exam. Let's get to it.
Section 1. Decoding the CKA exam. Let's get the basic administrative facts out of the way first so you know exactly what you're up against before stepping into the testing environment. Okay, the logistics. You've got exactly 2 hours to tackle 15 to 20 performance-based, hands-on tasks in a live version 1.30 environment. Listen, this isn't a multiple-choice test. You'll be interacting directly with real clusters via a Linux terminal. To earn the certification, which stays valid for 3 years by the way, you need a score of 66% to pass. Now, notice the massive 30% weight given to troubleshooting. That makes it the single largest domain on the exam. What does that mean for you? Well, it means you can't just know how to build a cluster from scratch or deploy an app perfectly on the first try. You absolutely must know how to fix it when things go spectacularly wrong. You've also got cluster architecture making up a solid 25%, followed by services, workloads, and storage.
Section 2. Why Kubernetes exists. You know, to truly administer Kubernetes and grasp the concepts for the exam, we really need to understand the historical problems it was built to solve.
Tracking the evolution of deployments. We started back in the traditional era, running apps on physical servers, where resource allocation was just a total nightmare. One rogue app would hog everything, leaving all the others starving. Then, we moved to virtualized deployments, using virtual machines. This isolated applications and better utilized the CPU. But VMs are really heavy, right? Each one requires its own full operating system. Finally, we arrived at the container era. Containers are lightweight. They share the OS among applications while keeping their own file system, CPU, and memory space. They decouple apps from infrastructure, making them totally portable across clouds. But this introduced a massive new problem. How on earth do you manage thousands of containers at scale without losing your mind?
And that is exactly where Kubernetes comes to the rescue. Fun fact, the name actually originates from Greek, meaning helmsman or pilot. You'll also see it abbreviated all the time as K8s, which is literally just counting the 8 letters between the K and the S. Open sourced by Google in 2014, Kubernetes acts as that helmsman, orchestrating the container chaos. It gives you a framework to run distributed systems resiliently, offering automated rollouts, self-healing, storage orchestration, and service discovery, all so your applications experience zero downtime.
Section 3. Kubernetes Architecture Explained. The crucial point here is understanding the machinery under the hood. Remember, this makes up 25% of your exam.
You can basically divide a Kubernetes cluster into 2 working halves, the control plane and the worker nodes. The control plane is the brain. It manages the overall state of the cluster. Its core is the Kube API server, which is the front end handling all REST operations. It relies on etcd, a highly available key value store, to actually save all the cluster data. Then you have the Kube scheduler figuring out where to assign workloads, and the Kube controller manager ensuring the desired state matches reality. On the flip side, we have the worker nodes. These are what actually run your applications. Every node has a kubelet, which is an agent ensuring containers are running smoothly, a kube proxy for network rules, and a container runtime, like containerd, to actually execute the containers.
But, it's equally important to define healthy boundaries here. Kubernetes is incredibly powerful, but let's be super clear about what it is not. It's not a traditional, all-inclusive platform as a service. It doesn't deploy your source code or build your apps. You still need your own CI/CD pipelines for that. It also doesn't dictate which logging or monitoring solutions you have to use. And instead of a strict A to B to C workflow orchestration, it relies on independent control loops to constantly drive the current state towards your desired state. It gives you the building blocks, but entirely preserves your flexibility.
Section 4. Pods and workloads. Let's see how this all builds into the actual workloads you'll be managing and deploying during the exam.
In the Kubernetes universe, the atomic unit of scheduling isn't actually a container. It's a pod. Think of a pod, kind of like a pod of whales or a pea pod, as a logical host. It groups one or more containers together. These tightly coupled containers share an IP address, they share network space, and they share storage volumes. They are co-located, co-scheduled, and they literally live or die together.
Here's the catch, though. Individual pods are totally fragile.
If the node they're running on crashes, the pods disappear, and Kubernetes treats that failure as final. You'd have to manually create a new one. Because of that fragility, you are very rarely going to manage bare pods directly. Instead, you use deployments to harness the power of self-healing. A deployment gives you declarative updates. You essentially tell Kubernetes, hey, I always want 3 replicas of this app running. And the deployment, working behind the scenes with a replica set, ensures that desired state is maintained. If a pod crashes, the deployment just self-heals the app by instantly spinning up a new one.
Section 5, Services and Networking. Once your workloads are up and running, you need them to be able to communicate. This brings us to the 20% chunk of the exam covering networking.
Because back-end pods are completely ephemeral, meaning they're constantly being created, destroyed, or moved around, their IP addresses are always changing. If a front-end application tried to talk directly to a back-end pod's IP, it would just break constantly. Enter Services. A service acts as a stable abstraction layer and a persistent IP address. It defines a logical set of pods, usually using labels, and handles load balancing the traffic across them. This ensures your front-end clients don't have to keep track of a constantly shifting landscape of back-end IPs.
Section 6, Troubleshooting for the exam. And this brings us to the largest and honestly arguably the most critical domain of the CKA exam, troubleshooting.
When a node goes down or hits a not-ready state during your exam, you literally don't have time to just guess what went wrong. You need to instantly check the specific node conditions. You're looking for things like, is it memory pressure, indicating the node is starved for RAM? Is it disk pressure, meaning you're out of storage? PID pressure from way too many processes running? Or maybe it's network unavailable, pointing to a misconfigured network plugin. Knowing these conditions inside and out helps you quickly diagnose the root cause. To actually dig into those issues, you're going to rely heavily on specific command line tools. If a worker node is failing, you'll need to jump right onto that node and carefully check the kubelet logs using the command journalctl-u kubelet. If your control plane is unresponsive, you might need to check if etcd is healthy using the etctl endpoint health command. Just make sure you pass in the correct certificate paths. Mastering these exact commands is basically what will save you when the clock is ticking down.
Speaking of the clock ticking, time is absolutely your biggest enemy in this performance-based exam. You have got to be incredibly efficient. First, set up aliases. Typing K instead of coup control 100 times will save you valuable minutes, I promise. Second, enable bash auto-completion. Third, rely heavily on imperative commands with the --dry-run equals client-o YAML flags. This instantly generates base YAML templates for pods and deployments so you don't have to write them from scratch. And finally, utilize your allowed resources. Bookmark the specific pages you need on kubernetes.io before the exam even begins.
Which brings us to our final and honestly probably most important recommendation: practice relentlessly. You cannot pass a hands-on exam with theoretical knowledge alone. Use free interactive environments like KillerCoda to run through practice scenarios. And definitely be sure to utilize the killer.shell simulator, which is actually included right there with your exam registration.
Knowing the map is one thing, but stepping into the territory is another. We've decoded the exam, explored why Kubernetes exists, broken down its architecture, and armed you with the exact troubleshooting techniques you're going to need. The only question left is, how will you pilot your cluster when the pressure's really on? Get out there, dive into those practice labs, trust your training, and go conquer the CKA.